In this video, I'm going to show you how to calculate the adjusted confidence intervals to reflect a within subjects design. And this is going to be in the context of a factorial within subjects ANOVA, specifically a 2x2. And the example data correspond to the plants and tidiness or cleanliness study in which professors' offices were evaluated for comfortability across 4 conditions: plants tidy, plants untidy, no plants tidy, and no plants untidy. So I'm not going to go through the entire analysis of this within subjects factorial ANOVA. I'm really just going to focus on obtaining the adjusted confidence intervals and then creating the corresponding line chart to represent the results. So the first thing that you need to do is you need to obtain the mean square error associated with the interaction term in the factorial ANOVA so that you can then do a very simple adjustment to it in order to get the adjusted standard deviation. So go into Analyze, General Linear Model, Repeated Measures, and the first factor is going to be Plants 2 and Cleanliness 2. So I'm having to do it from scratch because I've closed down SPSS. Put in your necessary variables into the within subjects variables box. Again, I'm not going to go through what an analysis like this consists of. I'm really just interested in getting the mean square error, and so I can click on OK. And if I scroll down to the table called Test of Within Subjects Effects, if I go down mean square error column, I can find 0.973 is the mean square error associated with the plants by cleanliness interaction term. And so if I square root that value, 0.973, I will get the adjusted standard deviation. 0.973 square rooted is 0.986. So 0.986 is the number I need to use to adjust the standard deviations associated with each of the 4 conditions. Now, to show you what the standard deviations look like, they are actually much bigger than that. So let's just look at the standard deviations quickly. So these are the standard deviations associated with the 4 conditions: 1.495, 1.78, 1.647, 1.74. I need to adjust all of those to 0.986, but I need to keep the means the same. So if I actually show you the means, I need to keep the means exactly the same. You can't manipulate that. I just need to adjust the standard deviations. So once I create variables that have a corresponding adjusted standard deviation of 0.986 and means corresponding to these, I can then use SPSS to create a line chart on those adjusted data that will produce confidence intervals that are consistent with the within subjects ANOVA. So the first step that I need to execute in order to get the adjusted variables to reflect the adjusted standard deviation, I need to create z-scores. So go into Analyze, Descriptive Statistics, Descriptives, and put the 4 variables into the variables box. Click Save Standardized Values as Variables and click OK. And SPSS has created 4 variables for me that have a mean of 0 and a standard deviation of 1. They're z-scores. Now I can transform those variables to reflect the mean from the raw data. I want to keep these means, and I want to adjust each one of these standard deviations to be 0.986. That can be done fairly easily. Go into Transform, Compute, and I'm going to call it Plants Tidy Adjust. That's going to be the first variable, Plants Tidy Adjust, and I want to put the mean, the raw score mean associated with that variable, which corresponds to 6.91, right here, 6.91. So 6.91 plus the multiplication or product of the z-scores and the pooled standard deviation, which I obtained from square rooting the mean square error of the interaction term, 0.986. And that will create for me a variable that has a mean of 6.91 and a standard deviation of 0.986. So SPSS has created a variable, a new one, called Plants Tidy Adjust, and it looks like scores from the raw scores. If you look over here, Plants Tidy, they look fairly similar, but they've been adjusted to have a standard deviation of 0.986. So let me prove it to you. mean and standard deviation. Click OK. And here it is, 6.91. I've got the same mean, but the standard deviation has been reduced quite substantially from 1.495 down to 0.986. Now I want to do that for all 4 of the variables. So I have to keep transforming. The next variable is going to be called plants untidy. And I just need to change this a little bit. Untidy. I need to change the mean. What's the mean for that one? 4.42. So right here, here's the mean, 4.42 for plants untidy. 4.42. Plants untidy adjust. Click OK. And now I need to do it again. Transform. And this one's going to be called no plants tidy adjusted. And I need to change this mean here to 5.93. That's the third variable's mean. 5.93. I need to change this variable to the z-score variable, which is the third one, no plants tidy, and multiply that by 0.986 and click OK. And transform one more time. This time here it's no plants untidy. And I'll just change that a little bit. It's really just the z-score here. I could double click and put it in there, or just change a couple letters. And I need to change the mean from 5.93. 3.96 is the mean of the last condition. And the standard deviation, of course, is always the same. That's the adjusted standard deviation, which takes into account the correlations across the conditions. So let's verify the variables. So I've got the 4 variables here, 1, 2, 3, 4, all adjusted. They should have the same means that they did in the unadjusted format, just different standard deviations. So let's look at that again. Plants tidy, statistics, means and standard deviations. And here we've got 6.91, 4.42, 5.93, and 3.96, which corresponds to the raw data means that are unadjusted. And look how the standard deviations are all the same, 0.986. So now that I've got the data in a way that reflects an adjusted standard deviation, I can go into Analyze, General Linear Model, Repeated Measures, click Define, and throw out these raw data, they're unadjusted, and put in the adjusted variables. And the plot of means can now be created. Plants, cleanliness going in separate lines, add, line chart, and the 95% confidence intervals. Now these 95% confidence intervals are going to be smaller than the unadjusted data. Click Continue, click OK. And here is what the chart looks like. Look how much smaller these confidence intervals are than the original chart. Let me just show you the original chart for comparison's sake. Yeah, so look at this chart here. This is based on the adjusted standard deviations, and this is unadjusted. Look how much bigger that confidence interval is. And it's the same scale, 4 to 7. 4 to 7, much smaller. This is how you should arguably reporting a plot of the means with confidence intervals in a within subjects design. And in the factorial context, if you're interested in depicting the interaction, you would use the mean square error for the interaction and simply square root that to get the adjusted standard deviation. So that is how you can do it the easy way when you have access to SPSS version 25 or greater. It's much easier to create the charts in that context.